Welcome, viewers. I welcome you once again in a very interesting and very important topic related to research in the field of social sciences and in the field of education. The topic on which I am going to discuss is very important and it is quite commonly used while doing research in social and behavioral sciences. Many a times we must have heard this term factor analysis. But have you ever realized what is this? Why this is used? Or in most simple term, what actually is the meaning of simple literary meaning of factor analysis? In this present video and in the upcoming video, I shall be discussing the term factor analysis in very simple way. I shall try to make the video as non-technical as possible so as to make you all understand the basic idea of factor analysis. Factor analysis is very much useful for researchers in the field of social sciences. Whenever they are developing scales and questionnaires, they have to use factor analysis. It gives them the confidence that the tool through which they are collecting data or through which they are collecting information is actually working in the intended direction. That is, it is having the reliability and validity. This technique is also used by the researcher after the data collection for data summarization or data reduction. This also helps in identifying the latent construct working in between the variables under investigation. Commonly, this is also referred as exploratory factor analysis and are widely used during research in the area of behavioral sciences. Sometimes we can also use this method for confirming the well-established theories involving the variables, which is known as confirmatory factor analysis. Factor analysis is also an useful technique before going for regression analysis whenever we have to decide that we have to perform regression, or in terms of determining the independent and dependent variables, the direction in which they are actually working, we perform factor analysis and it helps in deciding the direction of regression analysis or deciding upon or reducing. Most commonly, you can say that it helps in reducing or identifying the exact variables for which we have to perform regression analysis. So let us study the basic of factor analysis in this particular video step by step. Okay, viewers, let us understand what is the basic meaning of factor analysis. Here we have defined the factor analysis. Factor analysis is a statistical method used to describe variability among observed correlated variables in terms of potentially lower number of unobserved variables called factors. For example, it is possible that variations in 6 observed variables mainly reflect the variations in 2 unobserved underlying variables. This definition and explanation is quite hard to comprehend. Let us take it in some simple way. Suppose in a study we want to study a person's interest for a game, say cricket. Now to measure this, we can simply ask him directly whether he likes cricket or not. But do you think this gives you the clear picture? Sometimes he simply says yes. But to what extent his interest is, or in some context he has interest for the game and in some context he may not have the likeness. For example, when India is playing, then only he has got the likeness, or irrespective of any country is playing, he has got the likeness. Or in some other way, we can say if he has got likeness when a particular player is batting in the match. For example, for me, I have interest in cricket in all its context, whether India is participating or not, whoever is playing, whatever may be the tournament. But you also know that this is not same for all. So to study the interest in cricket of a person, we need to ask many questions, or in technical term, we need to collect information from several questions or variables. Your questionnaire may be having questions like, I always keep on checking the ICC ratings of players. I always keep the upcoming schedule of cricket matches. I know the ranking of all the cricket teams. I always try to buy ticket of matches if possible, etc. So there may be many such questions or variables like 80, 90 items. But it may be there that these questions or items, or it many a times the possibility is there that many of these items are related to each other. They are very close to each other, or in terms they are saying the same thing. So we can club these items together, or technically they have high degree of correlation. So the items which are having high degree of correlation with each other, or which in terms are similar, so many of these items can be clubbed together. So factor analysis can help us to reduce these variables. So here factor analysis can help us. Factor analysis can help us to reduce these variables and give us a set of factors in which the items can be clubbed, and thus we can get dimensions for the tools. Like in the above problem, we may have factors interest towards overall cricket game, interest towards the cricket players, interest towards cricket playing countries, etc. So in this particular factors, we can put the items. So performing factor analysis can help us here to drop out items or variables which are of less relevance or showing lower degree of correlation for the study variable. Also, it helps us to construct factors or latent variables which can be further used for regression equation and also for structural equation modeling or SEM. So we can say that factor analysis help us in data reduction and data summarization, and also in technical terms identifying factors which may be little bit technical, but we will try to understand them in the coming video or in the later part of the videos, like identifying factors, models of fit, factor scores, also surrogate variables, etc. Okay, let us try to get some more idea on factor analysis. Here we can see in this particular slide that it tells that factor analysis is a variable reduction technique. It also says that it produces a set of variables in terms of a small number of latent factors. This also I have made you understand in the above example of cricket game, or the likeness towards cricket. Here, where I told you that when you construct number of items, multiple number of items, those items can be clubbed together. Those items can be clubbed together to give us some latent factors. Those factors may not be observed through the items, but it is working in between the items. So we got those unobserved factors like likeness towards the cricket game, likeness towards the participating country, likeness towards the players, etc. Also, it says that factor analysis is a correlational method used to find and describe the underlying factors driving data values for a larger set of variables. So basically, whenever we are going for factor analysis, basically many of the statistics which we follow in the area of social science and behavioral science, the correlation is one of the major statistics that we use. Correlation has got multiple applications in the field of research in behavioral sciences. In fact, there are hundreds of different types of tests for which the base is provided by correlation or coefficient of correlation. So correlation is very important or very strong tool which we can use for different statistical calculation, and also in factor analysis. The correlation, the strength of that correlation is very much important to find out the underlying factors which are there. We can also see that in this presentation, it also cites that factor analysis is an interdependence technique whose primary purpose is to define the underlying structure among variables in the analysis. So we have seen in the example of that cricket questionnaire that the items are quite interdependent on each other. If there is no correlation between the items or very less correlation between the items, then also we cannot perform factor analysis. And if the items are very much correlated with each and every other items, or there is case of multicollinearity, then also we cannot go for factor analysis. So the interdependence should be there, but up to what extent it is there, that also is the matter of investigation whenever we are performing factor analysis. So we have to very minutely perform factor analysis to get the exact factors which are overall reflecting that holistic variable, that particular variable. That is a particular phenomenon which we are studying should be find out the factors which are working and reflecting that particular observation. So interdependence between the variables is very much important to determine the model of fit or to determine the factors. Again, it is clear from my previous explanation, factor analysis is used to condense the information contained in a number of original variables into a smaller set of new composite dimensions or variates, which are also called as factors, with a minimum loss of information. So as we have seen in the example of questionnaire of cricket likeness, or the questionnaire to assess the likeness towards cricket, we have seen that many of the items are being clubbed and different factors were identified, like the factors likeness towards cricket playing countries, likeness towards cricket players, or likeness towards particular game. So these all were the factors which we have identified. And when we compare with large set of question, 80 questions, 90 items, 100 items, and when we reduce it to number of items, number of factors to 4 or 5, in fact, we are successful in reducing the number of original variables into a smaller set of new composite variables or factors. Secondly, it is also the method for investigating the structure underlying variables. So through factor analysis, we can understand the structure which is working towards the observed variable to reflect the capacity or the extent of observed variable or that particular phenomenon. So whatever the structure is there, that we can identify, or model of it we can identify by performing factor analysis. Lastly, factor analysis is a mathematical model used to express observation in terms of latent variables. So whenever we perform factor analysis, we can give an equation where we can show that that particular observed variable is an equation of different other latent factors. So gives you a model of it, or mathematical model, where the observed variable is shown in terms of latent variables or hidden variables. Factor analysis is a significant instrument which is utilized in development, refinement, and evaluation of tests, scales, and measurement, as claimed by Williams and Brown in the year 2010. So factor analysis is used to construct tests, to assess the usability of the test, to construct different scales, different rating scales, different questionnaires, and different other tools of investigation. When we talk about the history of factor analysis has origins dating back more than 100 years through the work of Pearson and Spearman. You must have heard the name of Pearson and Spearman. Pearson has worked in the area of correlation. Spearman has worked too much work in the area of intelligence. So we can see that it is more than 100 years back, in the initial part of 20th century, the first decade of 20th century, that is 1904 or around 1900s, we can see that there are a lot of work on factor analysis. They have first used factor analysis while investigating different psychological constraints or different psychological variables. Factor analysis can be used while preparing test, scale, and questionnaire, as well as establishing the validity of a pre-established relationship between a set of variables, which I already told you that it is called as confirmatory factor analysis. So if there is pre-established relationship or pre-established theories relating to certain variables, so we can perform confirmatory factor analysis and we can verify if it holds true or not, or if there will be little changes, or we have to go for a new model. So confirmatory factor analysis works in this direction. Although maximum of the times we go for exploratory factor analysis, but confirmatory factor analysis is also used for some specific purposes, in different other purposes. Okay, factor analysis, as I already discussed in the earlier part, that it is quite similar to, or many of its functions are quite similar to multiple regression. Both of them have got the foundations established on the idea of correlation. That is, the correlation is the main statistics which works behind both these statistics. In fact, where factor analysis tries to identify or reveal the hidden factors or the latent factors working in different sets of variables, multiple regression tries to establish the relationship or try to find out the extent of relationship between independent and dependent variable, or the extent of two or more variables which are working in determining a particular variable. So factor analysis and multiple regression both are the statistics which are based on correlation. In fact, in different studies, first we go for factor analysis, and once we are able to identify the hidden factors or the events, once we are able to reduce the number of variables, then we can go for performing multiple regression and we can establish this relationship between the dependent and independent variables. So factor analysis help us to create a set of factors which has to be uncorrelated or which has to be independent from each other. So if we are performing factor analysis and we are not able to identify the factors mutually independent from each other, then we are not successful in performing factor analysis. So the real success of factor analysis is that we are able to get the factors which are independent from each other, which are uncorrelated, which are mutually exclusive. So that is the real success of factor analysis. Once again, we can say that factor analysis is used to reduce a large number of variables to a smaller number of factors for modeling purpose. As such, factor analysis is integrated in structural equation model. So we try to create SEM or structural equation model by reducing the number of variables to different set of factors. Factor analysis is done to select a subset of variables for a large set based on which original variable have the highest correlation with the principal component factors. So the factors which we are determining, they must have got high degree of correlation with the original variable. Suppose we have got 50-60 variables or items. So if we are able to get some factors, suppose 2 or 3 factors, so for a particular set of, suppose for 20 items we have got one factor, so these 20 particular items must have got very high correlation with these factors. Similarly, suppose the 30 items, other 30 items has got one unique factor, so that factor must have got very high correlation with that set of variables or that set of items. So what we are saying that the original variable have the highest correlation with the principal component factors which we have identified. So why I am saying principal component factor? So it is one way of factoring. There are different other ways of factoring: component analysis, principal component factors, simple factor analysis. So different types of canonical factor analysis, different type of factorings are there. So based on that, if you have identified the principal component factors, then that factors must have got some high degree of correlation with the original variables from where we have got this particular factor. Then only we are successful. Factor analysis explains variability among observed random variables in terms of fewer unobserved random variables called factors. We are calling the first observed random variable. Suppose we are preparing a tool, a particular test. So we have kept different number of items for that particular test, arranged in different order. We are not thinking about that these items should be the first and then the second items should come in that particular in a particular sequence, because we are going to perform factor analysis in the latter stage. So afterwards, when we get those factors, we will be able to arrange those items in a particular order. So once we are going for performing factor analysis on this set of random variables, we get some unobserved random variables or latent variables or hidden variables, which can be called as factors. The observed variable are expressed in terms of linear combination of the factors plus error terms. So what is this? So suppose we have got some factors after performing factor analysis. Suppose 2 or 3 factors we have got, like what I told when I was discussing about that test on likeness towards cricket. We got the factors: likeness towards the game, likeness towards the cricket playing country, likeness towards cricket players. So suppose these 3 factors are there. So overall variable or overall outcome is likeness towards cricket. So this likeness towards cricket can be expressed in terms of these 3 factors, that is likeness towards the cricket country, cricket playing country, likeness towards the cricket player, and likeness towards the game. So these 3 particular factors, and there will be surely some error terms will be there which we are not able to find out, which is also responsible to determine the likeness towards cricket. So we will be able to get a SEM or sequential equation model where overall observed variable, that is likeness towards cricket, can be expressed in terms of these factors. An equation we can derive. So this particular equation, many terms, will help us in further study or in designing that particular questionnaire or to investigate in this particular area or in this particular field. So factor analysis is originated in psychometrics. I already told that in the area of psychology, whenever we are going for multi-factor theories of intelligence and then personality, so there from that psychometrics, first factor analysis came, and later on it is used in different other areas of social sciences, marketing, product management, operational research, and other applied sciences that deal with large quantities of data, because there are large quantities of data and they must be reduced so that we can apply it in simpler ways or in meaningful ways. So factor analysis can help us. So suppose a marketing team of a car company is there which is trying to find out the test from which they can identify that which criteria is most influential or which criterias are most preferable in determining a customer in deciding on which car they are going to buy. Is it the car color? Is it the size of the wheels, or a different other set of variables? So he may create a questionnaire or set of items related to the car manufacturing or related to the car mechanics, etc. And then he can perform, and then he can go for factor analysis to identify the exact factors which are working in deciding which is really working, or which is latent factors, which is a hidden factor, which is really working in a person or in a consumer behavior on deciding on which car they are going to buy. So factor analysis can be used in different ways. Okay, now we will be discussing on various assumptions before performing factor analysis. What are the preconditions before we go for factor analysis? The first one is that there should not be the outliers in the data set. So the data set from which we have got the values, or whenever we collect data and whenever we observe that there are some outliers which are not in the trend of the entire data set, then we cannot go for performing factor analysis. Secondly, there should be the normality in the data set. That is, so when we plot the data set, or whenever the observed variable, whenever it is plotted, or the observed variables, whenever it is plotted, it should follow the normal probability curve. So there should be the normal probability curve trend in the data set or in the observed variable pattern. Now the third one is the adequacy of the sample size. So what is the adequacy of the sample size? So it determines, or it says that if our data set or the variables are sufficient to go for performing factor analysis. So here we have to use KMO test or Kaiser-Meyer-Olkin test. Now, what is this Kaiser-Meyer-Olkin test? This test is measure of how suited your data is for factor analysis. The test measures sampling adequacy for each variable in the model for the entire model. This statistics is a measure of the proportion of variance. Just try to understand. This statistics gives you a measure of the proportion of variance among variables that might be common variance. The lower the proportion, the least suitability is there for performing factor analysis. So the statistics is a measure of the proportion of variance among variables that might be a common variance. So when we perform KMO test, and when the proportion is higher, that the proportion of common variance is higher, then the higher chance is there for going for factor analysis. Now, so for reference, just try to understand, for reference, Kaiser put the following values, or the Kaiser gives the following values for deciding on performing factor analysis. If these values, particularly these values ranges from 0 to 1. So if the value is from 0 to 0.49, then it is unacceptable. That means we should not go for factor analysis, because a value near to 0 indicates that the sum of partial correlations are large compared to the sum of correlations, indicating that the correlations are widespread and are not clustering among or for few factors, or among few of these selected factors. So it indicates a problem for factor analysis. On the contrary, a value near to 1 indicates a good fit for factor analysis. So as I told you, the value from 0 to 0.49 is unacceptable. If the value is in 0.50s, that is 0.51, 0.52, like this, then it is miserable. The third one is if it is in 0.60s, or that is 0.61, 0.62, then it is mediocre. This whatever I am saying, it is stated by Kaiser. So these are the values. Now if it is in 0.70s, then it is middling. If it is in the 80s, 0.80s, then it is meritorious. But if it is in 0.90s, then it is marvelous. So if you got the KMO test value in 0.90s, then it is marvelous and you should go for factor analysis. So it is the most suited one. This sample adequacy is there and factor analysis can be done in very nice manner. Again, the third or the fourth assumption is that there should not be multicollinearity and there should not be singularity among the variables. Now, what is this? I think I have already discussed, or let me again discuss. Multicollinearity means that if all the variables or if all the items of the questionnaires are related to each other, all are related, there is some extent of correlation with each variable or each item with each and every item, then we cannot be able to find out different separate factors. So multicollinearity will be the problem. Similarly, if the singularity is there, singularity means if the items are not correlated with any of the other items or any of the other variables, then also we cannot go for factor analysis. So multicollinearity is a problem. And if singularity is also there, then also it is a problem. So there should be some extent of correlation among the variables. Then only we can go for factor analysis. Now the last assumption is that since factor analysis is a linear function of measured variables, it does not require homoscedasticity between the variables because we have got different factors. We have to identify different factors. So among these factors, if certain variables are involved, it is not required that homoscedasticity should be there among the variables spread in several set of factors. So homoscedasticity is not required. So it is not required that different set of items or different set of variables, there should be equal trends of variance or equal variances should be there in different groups of variables. So that condition is not required because different factors will add up to give that particular observed variable. So homoscedasticity is not required. Now the next assumption is that the variables should be linear in nature. The variables under investigation or the set of items for which we are going for factor analysis, they should be linear in nature. Second one, the data should be in metric scale or they should be metric in nature, that is interval and ratio scale. So data collected should be in interval and ratio scale. Next one, variable must be sufficiently intercorrelated to produce representative factors. So as I told earlier that there should not be multicollinearity among the variables, and to some extent it is also not that there should be singularity among the variables, and that I already explained. Similarly, there should be, as it is being said here, there should be sufficient extent of correlation among the variables so that they can produce some hidden factors or they can be clubbed into certain factors. So some extent of correlations should be there. Nextly, we have to go for Bartlett test of sphericity. So what is this Bartlett test of sphericity? So Bartlett test of sphericity tests the hypothesis that your correlation matrix is not an identity matrix. So what is the identity matrix? Identity matrix means only the variables are correlated with themselves. That means all other correlations are zero. That means the correlation between one variable to other variables is zero, and only the diagonal entries are one. So whenever we go for Bartlett test of scarcity and we get an identity matrix, then it will indicate that your variables are unrelated and therefore unsuitable for structure detection. So we should go for Bartlett test of sparsity, and whenever we in that particular test, if the test is significant, then only we go for factor analysis. That means it starts with the null hypothesis that your correlation matrix is identity, that is the correlation between the variables is an identity. So we start with the null hypothesis, and if in the result the hypothesis is rejected, or we can say that if the results are significant, then only we can go for factor analysis, or we can say that whenever we can see that that the correlation matrix is not identity matrix, then only we can go for factor analysis. So Bartlett test of sparsity we have to perform, and when it is significant or the hypothesis which is framed that our correlation matrix is identity is rejected, then only we can go for performing factor analysis. Next, we can say that the data should be collected from the homogeneous sample, and I think you understand what is homogeneous sample, that the nature of the sample should be same, and the sample from where we are collecting data, the sample or size of the sample should be 3 to 20 times the number of variables under investigation. Suppose your number of variable is 10, then at least sample should be 30 or 20 times, that means 200. From 200 sample you should collect your data, but at least the sample should vary from 100 to 1000, or if it is more then it is far better, but at least it should be 100. So sample size we can decide on number of items being investigated, but at least you should go for 100 samples so that you can perform the test, or we can go for factor analysis, and the chances of error will be minimized and the results are reliable. So now we will see the different types of factor analysis. I have already named them. I have already stated them earlier. One is confirmatory factor analysis and the second one is exploratory factor analysis. So as per the name suggests, the confirmatory factor analysis is whenever there is already established theory or established equations where we have got a particular model or a particular set of relationship among variables. So to confirm those established theory or established model, we can go for confirmatory factor analysis to say that our particular observation is also confirming to established set of variables or established set of relationship. It may be also there that once we are going for confirmatory factor analysis, we can confirm with the established pattern or established relationship among the variables, or we can modify or you can establish a new set of relationship among the variables, and we can go for finding out new pattern or new set of factors. So confirmatory and factor analysis is used for this purpose. So confirmatory factor analysis is less used once we see the trend of exploratory factor analysis, because exploratory factor analysis is most used by the researchers whenever they are going for certain investigation, whenever they are going for designing tests or designing a tool or constructing a tool. They have to go for exploratory factor analysis. They have to find out the hidden or latent variables or factors which are working in determining that observed variable. So whenever they are going for constructing the tool, or whenever they are going in the field and collecting a set of observed variables, or if the number of very large, then they can go for exploratory factor analysis, so that they can reduce those set of variables. That's why factor analysis is sometimes called as data reduction techniques. Once we go for SPSS analysis of data or factor analysis, there that particular technique which you are going to use is called as data reduction only. So exploratory factor analysis can be used in that way. So exploratory factor analysis is most used, but we have to use confirmatory factor analysis whenever the demand is there, whenever the requirement is there. So there are two types of factor analysis. One is confirmatory factor analysis, and second one is the exploratory factor analysis. So let us once again revise that what I told in the earlier part of this presentation. The confirmatory factor analysis seeks to determine if the number of factors and the loadings of measures or indicators variables on the term loadings of measures variables on them conform to what is expected on the basis of pre-established theory. So confirmatory factor analysis tries to determine the number of factors and the loadings of indicator variables on them and confirm what is expected on the basis of pre-established theory. So that I have already explained. So whatever established theories are there, that it is trying to verify or trying to confirm. So confirmatory factor analysis tries to do that one. And what is exploratory factor analysis? So exploratory factor analysis is used to uncover, to explore the underlying structure of relatively large set of variables. And this is the most common form of factor analysis. This is widely used by the researchers, or in any type of research. We are going for finding out the we are going to explore the underlying structure among the variables. What is the specific latent unobserved variable which is there working in between the variables. So exploratory factor analysis is the most common field of social sciences, in the field of marketing, in the field of business, in the field of industries. So factor analysis is particularly confirmatory factor analysis is used in establishing new structure equation models. Now we will briefly understand. In this particular video, I have given the basic idea of what is factor analysis, what are the assumptions before going for factor analysis, and the two different types of factor analysis, that is CFA, and the exploratory factor analysis, that is EFA. In the upcoming video, we will try to see the different technical terms related to factor analysis, other technical related terms, and we will also investigate the different steps of performing factor analysis. In this particular last part of this particular video, which we are discussing now, I will briefly describe the steps of factor analysis. So you can see, and I will be discussing it in detail in the next video, but just you first try to see the steps. Just try to get the names of that particular steps. The first stage is, first we see our research problem. If our research problem demands exploratory factor analysis, or it demands confirmatory factor analysis, so we have to decide our objective. We have to go for EFA or we have to go for CFA. So we also decide that we have to go for data summarization or we have to go for data reduction. Sometimes we are going to write up about a particular outcome on variables. That means we are going for data summarization. And sometimes whenever you are constructing your tool, then you may go for data reduction. So it depends what is your purpose. You are going for data summarization or you are going for data reduction. So if you are going for confirmatory factor analysis, then we are going for structure equation modeling. So you have to go and confirm with a particular model which is already there, or we have to change in that particular established model if there is certain changes observed, then we go for new structure equation modeling or SEM you perform. Otherwise, you go for exploratory factor analysis. So you decide that you are going for CFA or you are going for EFA. In the next step, we have to decide on which type of factor analysis you are going to perform. There is two types of factor analysis in terms of calculation, which technique you are going to use. One is Q type of factor analysis, which very much depend upon the responses of the sample or of the subjects. That is, subjects responses to that particular variable and relationship in between the subjects responses, that plays a major part in performing this factor analysis. The second one is R type of factor analysis, which is most commonly used, which I will be discussing also, and every researchers try to use that one only, which depends upon the relationship between the variables, not between the responses of the samples, which is of Q type of factor analysis, where the responses of the sample or the subject responses, there we go for seeing the clusters, different types of clusters, in trying to find out the pattern of their responses, and then we are going for certain factor analysis. So that one I'm not going to discuss. So basically we used to do factor analysis on the set of variables or the items on which we have collected data. That is called R type of factor analysis. R is for relationship, so correlations factor analysis that we are going to do. Nextly, we decide on which way we are going to collect our data. Is it a ratio scale or is it an interval scale? What is the size, or what will be the size of the sample? And what are the variables which we are going to include in our factor analysis? So how many variables will be there? What will be the way we are going to collect data? What will be our scale on which we are measuring the data? It is an interval scale or a ratio scale, because we have to collect data in metric scale only. And what will be the sample size? So that one we will decide. So first we decide which type of factor analysis we have to do, Q type of factor analysis or R type of factor analysis, and then we decide upon our tool, the scale on which we are going to measure, and then the sample on which we are going to collect information from. So next we have to verify, or you have to see that whatever assumptions of factor analysis is there, that I have already discussed, the normality, the homogeneity constraints, and the homogeneity of the sample, KMO test, the Baldrett test of sphericity. So all these assumptions has to be tested, and then only we can proceed then we can only proceed for performing factor analysis. So in the next step, which is stage 4 and stage 5, this particular presentation must be looking to you very confusing or very complex. I will try to explain it in the next presentation in detail, but in this particular presentation, let me briefly make you understand what exactly it is saying. So first of all, we have to decide on which factor method we have to use. So there are different types of factor method. One is principal component analysis. Second one is simple factor analysis. Third one is canonical factor analysis. So there are different types of factoring methods are there. So decide on, based upon the context or based upon the objectives of the investigation, you decide on which type of factoring you are going to use. The principal component analysis or factor analysis or canonical analysis, or different other types are also there. Then you identify the total variance, and then you also identify the common variance. You make the matrix, correlational matrix. Then you have to go for correlational matrix. So first you decide on the method of factoring, then you identify the common variance, total variance or specific variance also, and then you go for constructing the correlational matrix. So once you construct the correlational matrix, you have to decide on the method of rotation, because it is not that all the factors will be very much smoothly visible to you once you identify the factor matrix, or once you go for inverse correlational matrix. It is not that you will able to see the factors very smoothly or very cleanly. So you have to rotate the factors so that there will be smoothness, or there will be, you will be able to observe cleanly or smoothly. You will be able to see what factors are there, which factors are responsible for maximum or optimum level of factor loadings. So those factors only has to be extracted which are responsible for maximum number of factor loadings. So you will go for, there are two different types of rotations are possible. Oblique method is there, orthogonal method is there. It is quite suitable that you use SPSS to perform factor analysis. So you have to go for either orthogonal methods or oblique method. So orthogonal method is there and oblique method is there. And once you use SPSS, you will get different options of rotation. Once if you choose orthogonal method, you will get Varimax, Equimax, and Quantimax. And if you use oblique method, there is Oblimin, Promax, and Ortho oblique method. So after rotation, you will get the factor matrix, and you can see that if you are able to get significant loadings, and again you will able to see that if the factors can be named or if the commonalities are sufficient. So whatever factors you are able to extract, you should see that if they are sufficiently loaded the entire variables, and if the factors can be named or the commonalities which you have found is sufficient or not. So after that, you can again decide that if you go to for further rotation or further factoring, so that you can get a clear or desired set of factors. So again, you can go for factoring, and again go for rotation, and again you can get the factors which will be desired for the observed set of variables. Lastly, you can decide on validation of the factor matrix. Do you go for split or multiple samples? Do you go for separate analysis for subgroups? Or you have to go for identify influential cases? Then in the last stage, you have to see that if you are going for summated scale, if you are going for factor scores, or if you are going for surrogate variables. So there can be different ways computation of factor scores related to the identify factors. You can get the factor scores that can be done with SPSS. You can go for summated scale whenever you are constructing a item scale or a questionnaire. You can go for creation of summated scale, or you can again get some certain selected surrogate variables which can be used in turn of those other set of variables. Means you will be able to identify different other variables from the given set of original variables. If you are able to get certain variables which can play as surrogate to other set of variables. So it depends. Identifying surrogate variables, it is not majorly used, but computation of factor scores is commonly used. And whenever you are going for creation of tools or test, you are going for creation of summated scales, you are going for using that particular way also. So it depends on which way you are going to use the factors which you have identified. So I think you have got little bit of understanding on different steps of factor analysis. I know you have not understood in very particular way, because that I will be covering in the next video, what is the different steps of factor analysis, but you have got a little understanding on what is the different stages of factor analysis. So in the present video, I have discussed on what is factor analysis, the meaning of factor analysis. I also discussed on different assumptions of factor analysis, and what is the two different types of factor analysis: confirmatory factor analysis and exploratory factor analysis. And also I have discussed in brief the different steps of factor analysis. So in the upcoming video, I will be discussing on uh, in detail different steps of factor analysis. I will also discuss different types of other technical terms like rotation of factors, like correlational matrix, like eigenvalues, like commonalities, script plot. So different other technical terms I will be discussing in the next video. So I think this particular video you should rewind and rewatch to make a clear image on what is factor analysis, the basic of factor analysis, and then you only go for the second video. Thank you.